So a problem string, I did one of them this morning, the 7 times 8, 7 times 80, 7 times 79, that kind of string. It's a string or series of problems intended to build relationships in the learner's mind so that strategies, models of big ideas, become natural outcomes. So it's less about direct teaching a strategy, and it's much more about building relationships and connections so that things sort of become natural that kids do. Now, we still then solidify it at that point. So it's not like, oh, naturally they're all just like brilliant, like wizards. We still have to, there's some distinct work that has to be done, but I'm going to suggest that very little of it is direct teach. And the only thing that I'm going to direct teach in a problem string is something that's social knowledge, by convention, things we deem to be so, like notation maybe, or vocabulary. Let me give you an example of that in just a sec. So I believe that math is figure out a ball. That's always going to be my first slide, no matter where I go. You already heard that spiel, moving on. The reason I get into high school algebra strings is because I did all this numeracy work. So if you want more information on that, down in the booth, we've got these guys moving on. Lesson structure is a specific structure that I learned about when I was doing elementary work. I find it very interesting that there's a few of us that were secondary that went back into some really interesting elementary work. You probably don't care about that, you're here for high school. The interesting part is I brought back this lesson structure, a couple other ones. But this is, I think, the inroad. If you've always been wanting to try something, but you're looking at Dan Meyer's rich tasks and you're like, whoa, that seems a bit much and uncontrolled and crazy, then may I offer you problem strings? If you're the guy that's like, no, bring on the Dan Meyer craziness, yeah, then may I offer you problem strings to do before the crazy task, to get the ideas percolating that the kids need to actually solve the task, or after you're done with the 3-act task, admit that all the kids are not necessarily really solid on the learning, and we need to solidify or cinch the learning. May I offer you a problem string? I think they are the missing link in the rich task sequencing, that if we can sequence using these little guys in between, then we can learn the math through the task. All right, enough of the background. Let's do some problem strings. So, can I use problem strings to introduce or remind about something that kids might have maybe percolated before? So can I introduce something or maybe remind about something? If I was going to be an Algebra 1 teacher, I might be introducing this. If I was an Algebra 2 teacher, I might be reminding kids. Here is a problem string to introduce or maybe just sort of remind stuff that kids might have done. I might say to kids, hey guys, you've seen this before, -2, 5. How might a mathematician represent that in some other ways? So I'm just like pulling on kids' prior knowledge. What might a mathematician do with -2, 5? What might kids say? They'll know. They might have a table. So they might sit over and they're, okay, x and y, they have -2, they have 5. They might have a graph, right? So I have a graph over here. Let's see if I can do this for -2 and 5. Okay, -2, so over there. Anything else?
Interval numbers.
Yes, so that's not the notation I mean today, and I'm just going to tell kids. I could be talking about interval notation, that's more of usually higher than that, and so I would say, not that. Cool. Anything else you might think of, and maybe in Algebra 2 class, kids might go, wasn't there that F thing? They might be careful about F thing. wasn't there that F? I would say, oh yeah, now if I'm in Algebra 1 class, I would go, hey, there's another way that mathematicians represent this, and they might represent that by F at -2, some function that I'm defining. When I stick -2 in, I get out 5. That's just a thing, and I'm going to directly tell kids. Weird, we came up with this notation, who knows? If it's Algebra 2, I'm reminding them. If it's Algebra 1, I'm like telling them. Yeah, this is a way that we can sort of talk about a point on a function. Maybe it's the only point on a function. Cool, the next problem in our string. So the next problem in our string, I might say to kids, so what if I told you f of 2, that same function, because it's still f, I'm naming it f, that f of 2 is -3. So, give me all the other representations. What are kids going to do? They're going to say, all right, if f of 2 is -3, then I might look over here at 2, and I might go down to -3. I'm not taking very much time to do any of this. About as much time as I'm doing here. Anything else? Well, I'm missing one. Yeah, the ordered pair. So, oh, Pam. So how about if I do it right? What should that be? 2 -3, right? A better presentation would have been to do it wrong and make you go, wait. Because kids will probably at this point go, oh, so is it the same? Function notation gets weird, right? Where does it fit? Maybe, I don't know, maybe not at this point yet. So then I might say, let's see if we can solidify this. You guys did that really well, you know what it means now. So if you know what it means, then f of 5 is -9. I let this one go even faster. Where would f of 5 be? -9. Now here, weird, that almost looks like those are linear. Strange. So let's see, what was this one? 5, -9. And then I'll put it in the table, -9. I write it as an ordered pair. and then I move on. And I say, so if I have this same function, and I tell you that that same function at 1, oh, actually I don't know what it is. I wonder what it is at 1. Huh. That's the next problem on our string. Go ahead. What is f at 1? Could students do that at this point? How might students reason about f at 1 right now?
Connect the dots.
They might connect the dots. So they might walk up to the board and they go, well, if it's linear, because I think it might be. Like, did you notice that I sort of prompted that a little bit? Huh, weird, might be linear, weird. And they're like, oh, sure enough, I think it might be linear. Well, if it is, then they could come over and they could draw something, and I could try. I wish I actually had a grid on. Note to self, next time I'll turn a grid on. I'm going to like change colors. Can you see the yellow? I'm going to try to see if I can, oh, how did I do?
Good.
Ish. A little bump in there. So if that's f, could I use the graph to go over to 1 and say, so at 1, where's the graph? Oh, it looks like it's like right there. So what's your guess? Looks like it might be -1. And then I'm going to pause. And I'm going to wonder if any students are like, well, if it's linear, we could do something about that. If it's linear, can you do something about that? Like find the equation of that line? Okay, find it. Go ahead. I don't know what it is. You guys are all staring at me. Wait, we have to work? Yes. So actually find the equation of that line. You have some points up there. Choose your favorite ones. Cute group. Totally displayed. I'm a loser. What are you thinking? How'd you do that? Who just said negative x+1? Was that you? Okay, Nicole's friend. How'd you do that?
I found that it's going.
Did you use the line that I drew?
Yes, I did.
Okay, so you could use the line that I drew and hope that I drew it well. Did anybody use the points?
Yes.
Okay, and did you also get negative 2x+1?
Mm-hmm.
Okay, so I'm just going to sort of hold that over here. We think it might be negative 2x+1. Maybe we could, as a teacher, can I not take the time right now to actually like use a couple points and, oh, that's how you, those points, good. Oh, great, maybe it is negative 2x. Sweet, even you read it off, it worked, good, moving on. I might continue to represent that in all the other ways. So I might say, what does that look like? Is that one -1? And we already graphed it on the table, and I would add it to, or in the graph, I would add it to my table here. Though I'm a bad presenter, and I didn't. I'm being techie for a second. I'm going to shrink my table so that I can. Yeah, it's really not cool. I should have done it from the beginning. 1, -1. Okay, so the next problem on our string, good thinking everybody, nicely done. What if I said that it's still the same function, but I don't know the x value? F at something is 0. Can you find that? What does that even mean? Now you know, because you guys own function notation, but your students don't, right? So I might do some work with them to go, what does it mean in the ordered pair? Where does the 0 go? Oh, it goes there. Okay, where does it go on the table? It goes there. So what are we looking for? Ah, we're looking for the x value or the y value is 0. Can you guys find that? Okay, what is it? Everybody yelled out. Looks like it's 1. Could I then, I'm not going to do it right now, but could I actually use this equation that we think it is and say, oh, so is it 1? Like, could we use this? What if that's equal to 0? So negative 2x equals -1. I think x might be 1/2. Good try. So that's a reason to actually sort of know the function rule. So it's not f at 1, it's f at 1/2. Cool. The last problem on our problem string, you guys are doing a great job. All I want you to do now is tell me, what's f at any x value? Okay, they're like, this is the coolest problem string I have ever written. Because at this point, what is f of x? It's negative 2x+1. Now you're math teachers, so you're like, okay, is that cool? Yes, that is really cool. Because what we just did was build function notation in a way that because kids are doing the relationships and connections in their own head, I submit to you they now own function notation better than ever when we just say, here's what it means, whatever that traditional stuff that we used to do. This is like my favorite problem string I've written lately, like ever. Would have been better with a grid on the screen. Put a grid on the screen when you do this, which is easy, right? Just like project Desmos or project a graphing calculator, just project the grid and then draw on the grid. I wouldn't have been doing anything else like putting points in Desmos or anything like that. I still would have been drawing on there. What do you think? Can you see how what I did was a series of problems that every time we had a little bit of conversation where I'm sort of nudging some ideas. Gee, those look a little linear, weird. I'm nudging a few ideas as I go. And I'm asking kids to then apply, maybe in a different way than they would have been able to. And a kid who's never heard about function notation, do I think they own it at this point? Nah, I'm not suggesting they own it. but do they have a pretty good sense of it? Would I want to do another problem string to follow this up, or a truly problematic situation, a rich task, to make sure that they really get, of course, they would want to do more work. Well, I say that. Do I have time? Let's see, it's 11:12. Maybe. I'm going to do this real quick. So, Pam Harris, ready? I don't know how to write this, so you have to like experience it. We were here, and our teacher said, we must teach them this skill. So I'm going to teach this to mastery, and now they are here. So I must teach them the next skill. So I teach that to mastery, and now they're here. Then turn the page, and wherever the next, teach that to mastery. And it's sort of this linear trajectory, on and on and on, until I'm done with my course, and I send them on, right? So we know, this linear sort of skill-based thing, we know, if we've been teaching for long, about 15 minutes, that there's a problem with that. Because our kids aren't here. They're here. So if I do this, which is what we've traditionally done, a skill thing. These kids are the teacher pleasers. They're the Z's in the room. They're the memorizers in the room. They go, okay, I will happily memorize that thing because that's where I'm going to get rewarded for. We get a grade. These guys do it a little slower. These kids are bored to tears because they're like, really? Seriously? You don't have to memorize that. I can just see through it. And they wreck our room. These are the ones that wreck classroom management. And these kids have no access. They can't enter. So I'm all about equity. But I talk about equity a little bit differently. I want to give everybody access. In fact, my equity looks like not allowing these kids to get away with a spit-out memorized answer. I want them to actually understand what's going on. I want us all to have real math. So, if this is what we've really got, don't do this, do this. Which means I've got to have a task, a lesson that all kids can enter. It's low threshold enough, high ceiling enough, that these kids can enter and these kids are flying. So I would suggest that through this, I've got kids that are like, all right, yeah, and I've got these kids that are like, hey, the F, and then the thing, and they're still making sense of all of it. So if everybody learns and everybody grows, then I got to come back in and do it again. Everybody learns and everybody grows, and I got to come back in and do it again. So I'm not going to do usually a problem string. I'm going to often do a series of problem strings. Or I might do a problem string followed by that rich task, followed by that problem string that keeps everything building and growing. So one of the things I'm talking about today is I'm the new author of Discovering Advanced Algebra, and I'm thrilled to be involved in the project because I love the original authors. They're awesome. It's one of the places where I learn more real math than probably from anybody else. So when I came on the project, they said, we want your footprint in this project. And I said, can I write a problem string book? And they were like, what would that look like? Anyway, lots of conversation. And so we've written a problem string book for the Algebra 1 book and for the Algebra 2 book. But the kicker is, we wrote it really to be bookless. So anybody can buy these. These are samples that we're giving away free today. It has the introduction and a chapter. So this has quadratics for Algebra 1, quadratics for Algebra 2. The whole thing will have like all the Common Core 6 standards. I don't make any royalties off these, just so you know. So I'm not right now pushing anything that I make money off of. I just wrote them. They're pretty good. Okay. And I'm pretty excited about the work. What I wanted to show you was, in that work, we give you the problem string, and then we give you dialogue and questions that you can ask kids, and then we give you, here's what your board should look like at the end. How'd I do? Did my board look somewhat like this? Ish. Look at that little screen. Don't write on an iPad in your class. Be on a blackboard or a whiteboard. Have lots of room. And leave a record of the work. It's really important. In a problem string, you don't do something and erase it. Like, I hate actually being on this stupid white, because I don't have enough space. So I actually have to sort of plan. You saw how my table was like squished in there to be able to get enough on there. So we give you that, and then we also give you a page after that, which I don't think I have next now. That looks like, we call it Pam's notes or Kim's notes. Kim's a colleague of mine. Where we give the problem, I'll stand in front of here so I don't thrash my voice even more. We give the problem string, and then next to it we give little bullets of things to think about while you're delivering it. We really tried to make it really like deliverable. So we give you all the stuff to study, and then we give you like the shorthand to go and deliver it in your class. Yeah? Huh? I've been thinking a long time about what that would look like. I'm trying to create an app where you open the app and it has the string, and then you over and it has the sample final display, and you over it has Pam's notes. Right? And then you just hold your phone while you deliver it in class? Rather than hold my index, see, I wouldn't have to carry these around anymore. Okay. Okay, so now I'm not going to show you my, I will. So, one purpose was to introduce or remind. Another purpose of a problem string could be some relationships we've developed over time, but we're not sure how to help students develop. In other words, you have some things that you do when you look at problems, and you're like, well, I do that, but I don't even know, how would I teach kids that? Or you're in that X group and you're like, of course all kids do that. That's a natural thing. I want to help all of us to develop some, like what? Pam, give me an example. No, I don't want to do that yet. So, oh crap, that means I just, okay, I'm going to do it the way I don't want to do it, but I'm going to do it anyway. Ideally, I would do these two problems with you. Will you bear with me? I think we'll save time not doing it that way. So I would give you a problem. Oh, we can do it this way. Can you guys promise not to look at the rest of the problems? If I give you the whole string, can you not look at the rest of the problems? Can you be adults like that? Probably not. So the first problem I would give you is this system of equations, and I would say, hey, if x equals 3/2 y minus 4, and y equals, you could read it up there, then solve the system. So don't look below, don't look below, thou shalt not look below. You guys just solve that really fast? I don't know how fast it's taking. Is it fast? You guys like each other, this is awesome. We got like 5 people on 2 chairs up here. This is Minnesota nice. Did I say that right? Was that a good use of Minnesota nice? Yeah, I'm learning. All right. Only been here 48 hours.
Can you read the fraction?
Absolutely. X equals 3/2 y minus 4, and y equals the opposite of 3/2 x plus 7. Anybody middle school and just notice how I said opposite instead of negative? That's kind of purposeful. That doesn't mean I'm never going to say negative, but I am going to say opposite a lot. Some of you are like, I don't want to solve it, I'll wait. I have no idea what the solution is. I guess I could be solving it too. Okay, tell me this. What are you tempted to do? Why? I've already done the work of isolating variables for you, right? So did you make a decision about which one you used? Yeah, how did you make that decision? Like, did you plug in x down here? Or did you plug in y up here? So, thumbs up if you have an answer, you have a thought why you did it. Nicole, do you have a thought of why you did it?
Yes. I don't know that. Nope. I'm not gonna judge it. I'm just gonna say it.
Excellent.
Thank you. I really just like the y equals, and so I just substituted in for the x because I really.
Wait, so this stuff went in up here.
Nope, other way around.
No.
The x went in.
This stuff went
Yep.
in down here.
Because in my head told me that I just need to have the y isolated on this side. So today that's how my brain wanted to do it.
Okay, excellent. Does anybody have a different reason for choosing one or the other guy in the pink shirt? Or peach shirt?
I substituted the other way.
Okay.
Primarily because
You took this stuff
Yep.
and shoved it up here.
Yep.
Tell me more.
I like to get X first before I get my Y.
Okay, so random reasons. Okay. Does anybody have a reason that is maybe not quite? It's fine. I get it. You wanted y equals, you wanted x equals. Or could there be other math reasons? Yes.
So I substituted the x into
This stuff up here,
Yep.
you threw down here.
Right.
Why?
So typically, when we're like graphing a function, for example, we want it in terms of x. So it's easy for us.
So that kind of feels like what Nicole was saying. Y equals. Then I can throw in a calculator. Like that's a decent mathematical reason. I think we have some other reasons. Yes.
Because if you put the other way, then the 2 goes into the 4 and you don't have a fraction anymore in the second. If you multiply through.
If I throw this stuff, x, down here into this x, then there's something about this 2 and that 4.
That will,
So either way, I'm going to end up with some fractions. But that way, I'm going to end up with fewer fractions. That's interesting. Maybe you didn't see that at the beginning. Maybe now are you going, ooh, that might be something for me to look for next time. That's one of the huge ideas of a problem string, is that you might not think of it, you solve it however you do, and then we share a little bit, and you go, ooh, I want my brain to do that next time. Okay. And you like prime your brain to go, ooh, all right, bring it. Give me another one. I want to try that. Right? And so then I give you another one. Did anybody have a different mathematical reason than that? Yes?
I substituted the y equation above, so I did not have to distribute a negative sign. I didn't have to deal with the opposite in front of
You didn't want to deal with this negative 3x deal it timesing stuff, multiplied by stuff. So instead you shoved all this up here so that you didn't have to distribute the negative over something. Okay, that's reasonable. Often we try to like help kids. Don't do it that way. You have to distribute the negative. Put it over here, and then because we're just like trying to save them from error. So I would suggest in a classroom we would want to do both and let them come up with that. They'd go, oh, if I did it that way, I wouldn't have to distribute the negative, and I'm not good at that. So maybe I'll try to keep the right. So some nice mathematical reasons. Cool. Then I would have you solve the second one. Has anybody already worked on the second one? Oh, by the way, what was the solution to the first one? 2, 4, is that right? The ordered pair 2, 4? Okay, I'm looking at the time. I'm trying to look at the time. How much time do I have in here? An hour, right?
Yes.
Okay. Okay, let's take a second to solve the second one. This guy right here. Any urges? maybe before you go too far, you guys are totally thinking substitution for that second one, right? Like that is the first thing on your mind. Anybody wanting to solve for one of those variables? You're laughing. You're like, no, not in a million years. So are you starting to think elimination?
Yeah.
Cool. So somebody eliminate really fast. Now I would be walking around normal class. I'd be walking around. I'd be looking at what you're doing. I could do that, but then the mic's up here. Don't have a mic in your class. So I'd be walking around looking at what students are doing. I am really using this as a formative assessment time. I'm seeing where my kids are and the kinds of things they're trying. If they're stuck, I'm nudging a little bit with a little tiny Michael Persson hint. You guys know him, Twitter guy? If you're not on Twitter, the only thing I do on Twitter are math people. I don't do anything else. I don't do Facebook either. I don't do social media. I don't have time for that. But I do Twitter. So when Sarah talked about this Twitter blogosphere, that's what MTBOS stands for, by the way. It's Math, Twitter, Blogosphere. Did I even get that right?
Yeah.
I don't even know. But it's this group of people that were like, what if we connected across the world together? So people often will ask me, how do you join that? Oh, you just do. Like you just say, hey, I'm in there, and people go, cool. Like they don't go, no, you're not. I've never seen your application. It's not. It literally is just about, you just sort of start following that hashtag. If you don't know anything about Twitter, ask me later. I'll help you get started. It's a weird world, but there's some really cool stuff going on. I'm totally rambling, so someone will solve that stupid system. What's the solution to the second system? Yes, sir?
Yeah, 2-4.
2-4. So if we were to graph these two systems, where would they all intersect? They would both intersect at 2-4. I'd have 4 lines intersecting at 2-4. In fact, does anybody notice anything else about these two systems? Ooh, we have a noticing right here. Before you answer, is anybody else noticing anything about, oh, now we have more answers. Notice how that pause gave more people a chance to find it before she gives it away. I want more people to look for a connection. Can you give us a hint without giving it away? Ooh, that's hard. Watch what I just did. I just took this kid in the room and I challenged this kid. Don't give me the answer, don't give it away. Give me a hint. That's hard. Hints are hard. You got one yet? Look, I just called you Einstein. Did you catch that? Go ahead.
Moving the equal signs between the
Moving the equal signs. It's an abstract hint. I was actually looking for the word obscure, but abstract came out. Does anybody have another hint? I saw several hands. Okay, white sweater.
Can you multiply the first one by something?
That's a hint. A little less obscure, maybe. Go ahead.
You make a table of values.
If I made a table of values, what would happen? I'm not sure anyone in here is actually going to do that, but we could. Go ahead.
Do something with the first system to get rid of fractions.
Something about getting rid of fractions. So if we were to get rid of fractions in the first one, what would happen? So these two systems, I'm not going to take too much time, but I would with kids, right? They're equivalent. They're the same systems. They're not just equivalent, they're the same systems. All I did was just mess around with the fractions. I solved. So then I want to have a conversation with kids. So do you always just want to, you guys were instantly like, oh yeah, we're going to substitute, hands down. There's no elimination happening here. Could we have cleared the fractions and then had this thing that no way you would have substituted, you would have eliminated? So I raised this idea of when do I want to substitute, when do I want to eliminate, and other nice things that came up at the same time. Now, for this presentation, I was actually going to then show you the rest of the string. So you can now look at the rest of it. I free you to look at the rest of it. So then could I ask something like this and then say, so if there's this idea of substitute or eliminate, how are you making your choices? What would you do for this one? Turn to the person next to you. I want you to look at this one and this one. And if you have time, look at this one. I want you to have a conversation between you and your friend. Meet them, by the way. If you haven't said hi, say hi. Would you eliminate or substitute for the rest of those systems? Go. Okay, when you see me do this.
Yeah, I'm still looking.
I wonder if what you just did in that conversation we could categorize as mathematizing. What do you think? Is it a little bit different than me going, okay, everybody ready? This is substitution. This is elimination. Now, do these problems with substitution. Do these with elimination. Like how often do we say to kids, let's develop, hey, how many of these did we ever solve? 14,063. And on the 14,062nd, we were like, dude, I think I'm going to substitute when it's like this, and I think I'm going to eliminate when it's like we came up with some ideas in our heads that we look at them and we're like, oh, all right, duh. we have these like sense of when we're gonna do stuff. How, could we develop that in our kids? I think this might be a way. So if we have some stuff floating around, that's really been my trek these last few years, is for me to listen to people and go, what are the things that you've picked up after the 14th million thing that you've done? Oh yeah, you kind of have this gut feel. Could we develop that gut feel sooner than the 14th million problem? I think we could. And I think it's actually mathematizing. So, there's an example. Let me give you another example. This one I was going to show you. I promise. So this problem string is all about think before you eliminate. That's what I called it. So let's just sort of walk through it a little bit. If I were to give you this one, how would you eliminate? Would you multiply both of them by something? Would you, or for that first one, would you just add them together? Yeah? So this, often the first problem of a string is a gimme. It's like, read and enter, it's easy, it's not too bad. That's not always true. In fact, the one we just did was not that way, right? With the fractions, that one was like, whoa, we had to do, wow, it took some, and many of you didn't even bother to solve that guy. So sometimes not, but often the first one's like a duh, we would just add it. But how about this, was there a question? No, okay. How about the second one? What would you do with this guy? Double the bottom. So this guy says he would double the bottom. Why would he double the bottom? Well, I know we want to get rid of the y's, but
Positive y and a negative y.
there's a positive y and a negative, but there's a positive x and a negative x. But this is a multiple of that. Aren't these things that we've developed over time? Could we develop that? Could I have kids say to me, and we could sort of share strategies? How about the third one? What are you going to do here? Run? Did you say run? Are the numbers ugly on purpose? Everyone go like this. They are. In fact, I'm going to be honest with you. I didn't notice that this one, this has a multiple of 3. These are all multiples of 3. That's not actually intentional, and it's a bad thing. So I'm going to change that. I got to tell the editors. Anyway, but I'm going to change that so that it's not all multiples of 3, because that's not my point. And that could come out. And so I'm tweaking. I'm like really purposefully designing these problems in such a way that certain things are going to come to light. And I didn't want, a strategy could be, well, gee, just divide it all by 3 and you have something easier. That's a great one. It's not the one I want to come out here, so I'm going to change that so that's not a thing that might happen. What are you thinking about for this one?
Doubling the bottom.
Doubling the bottom one, and bam, those guys go away. How about this one?
Tripling the top.
So I could triple the top. I could triple the top. Everybody good with that? What else could I do? Ooh, I can solve for y. But wait, it says eliminate. You daredevil, you. So I could solve for y, nice, and I want that to come out, but isn't there something else I could do too? Can I multiply that one by 7? And now I have, I think, 3 things. Actually, I haven't thought about, so I have to think about how the solving for y and substituting, how ornery that would be, but I think I would put all 3 of those up there. Let's multiply the one by, I already forgot, double the one, multiply the other one by 7, no, triple the one. Triple the one, multiply the other by 7. But then what I really want to come out of that is this idea that when I have opposite signs, we go, sweet, right? And when the numbers aren't relatively prime and we can only multiply one of them, sweet, like that. And I want that to come out. I want that. That would be an anchor chart I would make on my board. Like, ooh, if the numbers are not, I can just multiply one of them, yes. If one of them's negative, there's positive, sweet. I'm thinking elimination, baby. Yeah? Like those are things to look for. Okay, how about the last one? Crud. And so now we have a conversation about what it means when we have things that are relatively prime, and we sort of flip a coin and hope we guess right. And we could show doing lots of different things to solve that one. And so this is often the last problem, is often a clunker. So it's the one where, all right, what have we done? What have we applied? And now can we apply it? Sometimes it's not just harder. Sometimes it's like this, what did I do this morning? 5 times, I don't even know, 5 times 59? I do all sorts of different numbers. But that last one where I said, I came unprepared. Could you write that's a great move in a problem string, by the way. You do these helper, 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 and you get to the end and you go, actually, forgot the helpers. Sorry, could you guys write the helpers? And the kids are like, sure, we'll help you. Because they respect the fact that you care about them learning, and so they're like, yeah, absolutely, we'll help. Someone in the back's going, really? I'll write your dumb problems, but it's not because you forgot. Anyway, so that only works for so long. But amazingly, it works for longer than you'd think, which is kind of funny. Okay, now I gotta remind myself what's next. All right, so that would be another sort of purpose for a problem string. A third purpose for a problem string. What if I want to reinforce the learning that's been happening with a twist? And I think right now, I gotta think about that. Actually, I can do that, but then I am gonna need to change inputs. Or, Is that a line? I could just yell from here. That might be actually faster. So take a look at this problem string. Oh my goodness. So I might start with x squared. And I might, don't look at I have no idea what's up on my browser right now. None whatsoever. Hey, look at it, it's my website. That's a fine thing. Okay, zoom over whatever else is up there. Want to see my website? There you go, mathsfigureoutable.com. Okay, there we are. All right, stop looking at my website. I'm going to go to Desmos. And so free online calculator. If you don't know about it, ask me later. We don't have time. So, phenomenal tool. We built it into, it is our platform of choice in discovering advanced algebra, discovering geometry. Can I announce that?
I think so.
Stay tuned. I think they signed the contract yesterday. Okay, anyway. So embedded in the ebook are all these simulations and the data's in there, and you can open it up in your class and display it, and it's all sitting there, really cool stuff. But you can also just use it as a graphic calculator. So I can say to kids, y equals x squared, what do you guys know? And they could tell me what they know. We can put a couple points. I could turn this on projector mode so it looks even nicer, and you kids can see a little bit better. And then I could say, what would happen if I took that y equals x squared, pardon me for just a minute, cheat sheet. No. And I, instead of graphing y equals x squared, I replaced x with x minus 200. Then I squared it. I replaced x with x minus 200. Then I squared it. What would that graph look like? Where would it be? And what would be a good viewing window? Where can I go find it? Now, if kids are on an iPad at this point, often what they'll do is go, because you can do that with Desmos, which is actually quite cool. So I have to add this little stipulation if they're on any kind of a touch screen, that I have to go with as few moves as possible. What can you, like, don't go hunting and pecking for it. I want to actually think about what I know. So I would have, remember this is the reinforced string. This isn't the teach for the first time string. This is the reinforced string. So kids have already learned about horizontal translations. So I say to them, based on your ideas of transformations, where would it be? Okay guys, where is it? So what window would you change? What would you change, the x's or the y's to go find it? How? I need to go to the right? I need to go to the right. How do I go to the right? What number do I change? The minimum or the maximum? So I could maybe stay at negative 10 if I wanted to, but I'm going to go over here to maybe 210. Hey, look at there's the first one, and get that rid of that, and there's the second one. Now, do you like that viewing? Now I just dragged. Do you like that viewing window? That's not. It looks like could be absolute value. Like I'm not. So I would want to create a better viewing window. How could I change that to create a better viewing window? So real quick, I could do that. Instantly, I've gotten rid of some extra space. So defining a good viewing window is a little tricky. It's not about the viewing window. It's about something that shows the important aspects of the function, and I don't have a lot of extra space. You would establish that at some point. So how else would I change that so that I see more of a parabola and less of a whatever that is?
Make the minimum 190.
Make what minimum?
The XX.
The x 190. What about the y? Or the maximum? Keep it at 210? Hey, that's better. Could we then keep messing a little bit, but messing with the window, not the stretching and shrinking and stuff, but thinking about where it is, and not spending too much time on it. What if I then said to you, okay, fine, what if the new function is y equals x squared, but this time I'm going to subtract 750. Now, sometimes the reasons for the big numbers is so that if they are swiping, but I'm ignoring you, they're swiping for a while. So then I get to talk about efficiency, and I get to go, come on, can we be efficient here? What would it be? Where could I see that guy? Now, we're probably not going to be able to see all these in the same window, so I'm going to turn the other two off. I'm going to go back to the home sort of view. There, I'm kind of back where we started. Where am I going to look for that guy? What are you guys going to tell me? Yeah, where? Am I going to change the y, this guy a y, or that guy a y? You need to see the cursors up there. The minimum to what? Almost here TI users. To what? 7 what? 760 somebody suggested. Hey, okay. Can you I know it's, if you're sitting, can you sort of see it? Like, sort of see it? So what could I change to make it look more like I was sort of expected to change? Could we mess with the y max? And I don't want to spend too much time on this. I hope you can give me a little bit of an idea. So when I began teaching, what are you going to change it to, by the way? Negative 730, negative 740.
It should be larger than, it's fine.
It's fine. I agree. It's not great, but it's fine.
It'll work.
We can stop right there. When I began teaching, I taught with Demand and Waite's first textbook. I don't know what it's called. They were the grandfathers of graphic calculators. I learned so much from what they wrote. In every Blumen section, they would have, find a good viewing window 4. And I would be like, oh, that's like number 2. I skipped that one. I did, like of 1 through 39 odd, I did 37 and 39 to make sure I knew, before the kids had questions the next day. Next day in pre-cal, the kids are like, 2. I'm like, 2? The question of number 2 was 100 square root of x. Find a good viewing window. It took us a half an hour. My sense of functions and transformations at that point, that was a few years ago, was so bad, I had no idea where to look. Nor did I have any numeracy to think about even how I would open that window. There's your homework for today, 100 square root of x, find a good viewing window. Could I then finish this problem string with just some other functions like it, where I'm literally just saying to kids, so we just did that one, where would that one be, where would that one be? No, not rocket science, but I'm just sort of solidifying this idea. Could I have, in fact, I'm not even sure why I didn't do this. How come I don't have both a horizontal and a vertical in one of them? Lame. I'll fix that one. So this one should have, in fact, probably maybe here I would have, it depends, right? At this point, maybe I put an asterisk by this question and an asterisk by that question, meaning optional. So if we do the first one and kids are like, I have no idea where it is. Well, then maybe I keep the optional problems. And like, all right, are we good with the replace is the horizontal and the add on the end, the whole function and values, that's the vertical? Cool. Then I would add 2 at the end where I'm sort of combining. And then I might do something like this, where I add a different parent function. And I say, okay, for that new parent function, no, a little bit less. For that new parent function, what about these transformations? So anybody that's ever done transformations with exponentials knows there's like a surprise that happens because the anchor point is no longer 0, 0, right? And so now the anchor point doesn't have a y value of 0. And when I start scaling that anchor point, what happens to it? Ooh, there's something for you to go investigate. So when I start graphing 2 to the x, it goes through what point? 0, 0?
0, 1.
Exponential functions, right? Math aerobics makes math more funny. So there's it was so fun in pre-cal. Sine or cosine? No, seriously, which one? You should be able to tell, because it's not this one. Don't put the kids to sleep. Okay, so if I have help me, what are these? Exponential function, it goes to the point 0, 1, because any number to the 0 power is 1. We define it to be that way. So then if I multiply that 1 by something, that second guy is not just going to stretch. You're going to ask for one teacher, you're like, yes it does. No, it doesn't just stretch. It actually stretches the y-intercept as well, right? So that would be something that I can sort of solidify using this problem string. So I give these problem strings are strings of problems that I give one at a time, which is kind of like not how I'm doing it so much today with you. I'm doing it with you as teachers. One problem, solve, we chat about it, I model thinking. Another problem, solve, we chat about it, I model thinking, I draw out relationships to the problem before. Another problem, solve, chat about it, I model thinking, draw on relationships. I start to perk ideas of things that could come up later. So that by the time I get to things down like that, I have some idea. Notice how I kept 2 to the x, 2 to the x. Then I changed 5 to the x. All right, now we're going to mess around with different bases, not just different transformations to see what happens. So that could be another example of reinforcing with a twist. I think finding good viewing windows is a relatively, oh golly, how do you say it? Well, error, when low cost of failure. That's what I was looking for. Finding a good viewing window, you can just mess until you find a good one. Then the teacher needs to say, yeah, but how could we have used our knowledge of transformations to think about that? So it's very low threshold. Kids can mess, and then I can help abstract out and make sure that we're clear on why those guys are all working that way. Cool. Another example. What if I do a rich task? So you might not be that teacher. You might be the teacher like, those big, rich, crazy kids are open, I get it. Those are a lot to jump off on and try. I think problem strings are the inroad. I think they are the first thing to try. However, if you're the person that's ready to try the crazy, or you're the expert. In fact, I think I have a few in the room that are experts of these open-middled, really cool, rich tasks, then I wonder if problem strings could help cinch the learning in that rich task. I'm going to suggest that when you do a rich task, pick a Dan Meyer, anything he does. I write some good ones too, just saying. And I sequence mine, which is actually what I think I add to the work. I think he hugely added to the work by helping us all have language around 3-act tasks. I think I add to the work because I help you understand what to do before and after it, so we actually learn the math through the task. And what I don't have to do is teach the math and then you apply it in the rich task, or I get you excited and then I dump the math in your head. I don't want to dump the math in your head ever. I want you to experience it and construct it, and we do that through sequencing. And here's one of the ways we sequence. So let's do a rich task. Let's say that the rich task is something like this. So this is one of the Desmos screens that we embedded in Discovering Advanced Algebra. And if I hit play, oh, you probably can't see it. There's a basketball right here. The basketball, I just hit play, and it's bouncing. You see? And then we're not populating the table, we're making the kids read the maximum bounce height. The kids have to read how high it goes, and they populate the table. If I'm only collecting bounce heights, and then I plot it versus bounce number, what's that function? Anybody? Bounce heights, like how high it goes, and then it doesn't bounce up as high, right? It only bounces up a little, right? Right, you know this phenomenon? Have you ever, you know this, right? So what kind of function is that about, here's a hint. If those maximum heights decrease proportionally every time. So that's an exponential decay. So if you didn't know that, it is. If I were to say, hey kids, do this exploration, do this investigation, this rich task. I got kids dropping balls under motion detectors or using the Desmos simulator, either one. See, we've given you some options here at this point. But I've still got kids collecting data, and now they've got this data. Oh wait. Right? Come on, that was funny. So they've collected this data, and they've now got to write a function. The data's not going to be exact, especially since they're reading the max heights off. So they get crazy data, they write this exponential function, they mess with it a little bit so it fits. Whew, we're done for the day. All right, go home. How do I cinch that learning? Did it really happen? So one way I do that is I say, let's have a conversation. Here's the data, that's what it could look like. Let's have a conversation. I call that conversation a math congress. I pull on Kathy Fosno's research for that. Do you know there is a international math congress? Why am I yelling? Not in front of the mic. I don't know. There's an international math congress that happens around the world every 4 years, where mathematicians write up their work and bring it for comment and review. And so what I do in my classrooms is you do the work, and then I ask you to write up your work for comment and review to your peers. But I ask often specific questions. In this case, what I would not do is say, okay, you guys all collected different data, you all came up with these different functions, tell us how you did it. Boring. And I wouldn't get any math from it. There has to be active learning in the congress. So instead, I say to them, hey, here are the functions you wrote. There they are. Put them up. All the different groups, all the different colors represent different groups of functions. Tell me about their balls. That was unintentional. I have not taught high school for a while. Can you tell? That truly was intentional. Most of my jokes are intentional. That one was not. So if I, seriously, which one bounced higher? Which one did you drop from a higher drop height? Which one did you, right? Which one had a lower return height? Could you tell me that now? So organize them. I tell the kids then, put them in order. Which one's the bounciest? Then that's our conversation. That's our math congress. So math congresses change. They're not always just tell us how you did it. In fact, they're becoming, in my world, fewer. That's rarely happening. I'm asking them with their work to then do something where active learning happens in that congress. Okay, this is the problem stream, not a rich task session. So I do those too, right? Rich tasks, we talk all about rich tasks. Done with that. If I've done this rich task, then how do I follow it? How do I cinch the learning? What if tomorrow you walk in and I go, hey guys, yesterday, remember when we were doing that ball drop thing, and what do you guys had, and I wrote the sequence instead of can we pretend we're in geometric sequences instead of functions? So close. So we wrote the geometric sequence for your maximum heights, right? Remind me, what did the 1 stand for, and what does the 0.64 stand for? And if I had written the exponential function, I could have that, and I could be talking about the a and the b, right, the base. What did those stand for? Once we were like, oh yeah, this is what it stood for yesterday, then I go, what if we had a different bouncy ball? Notice how I just said bouncy ball. And this was the geometric sequence, or I could have the function written out, and I could say, what changed? What didn't change? What will change in a table? What will change in a graph? And I make all the connections between them. And then I say, how about this one? And we have the conversation. How about this one? And we have the conversation. And the clunker? How about this one? Can you still find? Everybody found one yesterday, but really, you were totally reliant on her. And I don't know where you were. You weren't even here. So, in that group, right, how many of them really learned how to write the function for, in this case, the sequence or the exponential function? Here's my opportunity to go, let's write one. Let's write one and let's get comment and hear from each other about how we're thinking about it. Does that make sense? So it's a way to sort of cinch that rich task. So if you're using rich tasks, most of you that I talk to, you're like, yeah, when we end it, I either feel it's too fuzzy, or I feel like I then just dump the math on them. And I want something different. I want to be able to construct the math. I think this is a way to do that. Another purpose that we can have for problem strings is to help develop strategy. Strategy. This is one of the things that I'm still really thinking about in high school. I've got strategies for numeracy. In fact, one of the things I did in my numeracy books was sort of, I think, kind of daring, where I was like, I think these are the 4 main addition strategies. I think these are the 5 main multiplication strategies that the kids ought to leave knowing. I'd welcome you to argue with me on that. I'm now coming out with, I'm researching, what are the strategies in algebra? You might even not know what I'm talking about if you haven't looked at my numeracy work. Well, so what does that mean, to develop strategy in algebra? And I think, at this point, yeah, I don't want to show you that. I need to change inputs. Thanks. Look, I managed to do that pretty much without having to change inputs, except a couple times. Sorry for the techie stuff. Are we up? Right, sweet. Okay, if I were to ask you, the problem I can't see, to solve this equation, what if I asked, good, great, where is it? There it is. If I said, hey, I've got this equation, x times the quantity x plus 3 equals, pretty sure that says, oh, not that one. Hold on, I gotta think for just a sec. Curse and swear. I know what I did. That's a Mormon swear word. Okay. I think I can do this from memory. Ready? If I give you x times the quantity x plus 1 equals 5. Will you solve that for me? Whatever strategy you like best, go ahead and, well, just solve that. Actually solve this one. Did I give you one that's not solid? No. Okay. I got people up here using the quadratic formula, so I was a little bit like, wait, I think, I mean, you could use the quadratic formula. That is a thing. That'll solve any quadratic equation, right? But I wonder if we could be more efficient. I wonder. So I'm going to look around and see what my students are doing, and then I'm going to purposely choose a couple people to share. So, will you share what you did? Kaya. Kaya?
Yeah, that's
Kaya, bring it.
I distributed the x.
Okay, so you got x squared plus?
Plus x.
Yep.
And then I moved the 5 over at the same time, so minus 5.
And then?
And then just factored x minus 3x plus 2.
X minus 3x plus 2. So close. I wish I would have looked a little bit close. Hey, can you, when you're thinking about, can you factor that one more time?
Oops, sorry.
No, you're so close. Go ahead.
X minus, no wait, hold on. It's 5, isn't it?
Yeah, that's a 5.
So no, I can't factor it.
Can anybody pick up where she left off? It's fine. She got us a great start. Great start.
5 minus 4.
Plus 5.
No, that's not what I meant. 1 minus 1.
Plus 5 minus 1.
Right? Nope, that's not what I said meant. I messed up.
Oh, this is what happens when I try to use my brain. I don't want it to be 6. I think I want it to be x minus 1. Sorry. Does that work? No. Okay. I'm a loser. 1 moment. Oh, so close and yet so far. This is what I meant. Nobody can see that, right? I wrote the wrong one down. I have 2. Okay. Moving on. It was late last night. X times x plus 4 equals 5. There. Now you see how good my memory is when I'm nervous. Oh, sorry. Okay, can we still use Kaya's strategy? For time's sake, we just run with me. If I were using Kaya's strategy, she would have done x squared plus 4x minus 5 equals 0, and that factors into x minus 1, x plus 5, and so the solutions are what? Negative 5 and 1? Is that right? Yeah? A fine strategy. Then I would have another kid share, and I didn't have time to look everywhere. So did anybody think instead like that? Did anybody think about something like a number times a number should be 5?
Yep.
Okay, so pause for a second. If you didn't, could you? Okay, so right here, Stripe, tell me what you did.
So I looked at 5 and I knew I had 2 numbers multiplied together.
Yep.
And so the only 2 numbers that multiply to give me
Are they?
Well,
Are those the only two factor pairs of 5? Come on, middle school teachers, where are you when we need you?
they're not. Negative 1 and negative.
Okay, so keep going, good job.
So, but I first noticed that if I used 1, then if I let x be 1, then I had 1 on the outside and 1 plus 4 is 5, so 1 times 5 is 5.
Sure enough. Yeah? So we've got one solution right now. We know that x equals 1 is one of the solutions. How could we find the other one? How did you, did anybody that used that strategy find the other one somehow? Find your way. Trial and error would be one way. So actually, oh, you have, who are you pointing at? You were pointing. So I could try them all. I could try them all to see which ones works. Is there another way that I could think? Now, I'm not actually going to, do you have some? Go
Well,
ahead.
I mean, you need, if you think that the answer is positive, that your number on the outside and that sum on the inside are both gonna have to be negatives, so.
Does that make sense?
Yeah.
If I've got two things times each other, I'm trying to change colors to something exciting. If I have two things times each other that have to be positive 5, either both of those factors have to be positive or both of those factors have to be negative. And I would want to follow this up with one where the 5 was negative, so then I would go, oh, one's going to have to be positive, one's going to have to be negative. And I pull that out of students. Look how I just did that. And what's crazy is almost always, she's in the room. Almost always I can go, is anybody thinking about it like that? And one of them's like, you want to know what I'm thinking? I mean, that's the usual, no one's ever asked me what I've thought before. And I pull it out of what they're thinking, and we get this phenomenal mathematizing happening. Here's the other thing. Guess who it's totally not you. It's not always this guy. Often, it's this guy. Because they can't memorize. This group of kids doesn't memorize. And so they've always been thinking and reasoning. There's a lot of holes because they haven't been able to think and reason with everything, but they try. And these are the ones that I look for to try to pull stuff out of. Now, often it's this guy too. It's honestly rarely the teacher pleasers. Because the teacher pleasers aren't thinking. They're just trying to mimic me. That's your hardest audience. Isn't that interesting? Which is one of the reasons why I like coming here, because you guys are here on your own volition. Like this is not a PD where you were forced to be here and you're grading in the back of the room. Like those guys are the hardest people to change. Oh, you're interested. You want to innovate, right? So you're like, oh, let me think. So I just want to warn you right now. The teacher pleaser kids are your hardest audience. They have to believe that what they've been successful in up to the point that you had them, you guys are high school, they've been successful for a long time at just giving the right answer and mimicking the teacher. They have to believe you that they're still going to be successful if they really actually venture out into thinking land. It is a very insecure place for those kids. Once they believe you, once those teachers believe me, they become my most ardent supporters. Then they're like, oh my gosh, I can just think about all that stuff I memorized. Problem strings are an inroad. I think it's a place to start to try if you've never tried anything like it before. If you are that rich task teacher, I would love to talk to you. Because one of the things I want to do is start writing problem strings for your rich tasks that you're developing. And all for free. We'll just stick them out there and let people start having those resources accessible so that we can get more people on the bandwagon. The more brains we get involved, the better it gets.